We'll proceed in summation to integral calculus. Summation to integral calculus. Okay. Summation to integral calculus. Okay, people would kind of think that we are trying to repeat something that is, if you want to calculate area, then they divide the area into n different parts and then calculate area of one part and sum it, it will become fx dx. We are not trying to repeat same thing, but anyway, when we are coming to integral calculus at the end, it will be same thing, one thing. Second thing is that we are, our problem, whatever problem we are seeing, we are trying to divide into many parts, and that part may not be the area computation. That part may be different, but actually we are trying to bring it into area. That is true. But we are not dividing anything, any area into n part and then calculate the area of each part and then make it is integral calculus. That is not true. We have a problem domain, and from problem domain we are trying to solve through a normal way, and then when we come to repeated summation, then we think that how I can bring it to integral calculus. To bring it to integral calculus, first of all we need to have multiplication of two items. One by gx into fx into log x dx into x. This will not be transformed into integral calculus. Integral calculus needs fx dx, fx into x. That will get converted into integral calculus. So integral calculus is of integral fx dx means if this is x-axis and over this x-axis there is a fx wave, continuous wave. Then if I do fx dx and integrate x from a to x b, then underneath a to b, whatever the area is, we calculate. Indeed, we do this. What we do is whatever summation, because when we have problem, we don't know that we need to use vector. We need to use integral calculus. We need to use algebra. We need to use statistics. We need to use probability. Whatever, statistics and probability are not different things. Main thing is algebra, calculus, and vector only. Okay, whatever the way. Then we start with a simple thing, and slowly once we start obstructed, confused, obfuscated in that fashion, since then we start thinking about using either algebra or using the calculus, using the vector whatsoever. Okay, again at the end we feel that we cannot compute it. Then finally we think that we can use integral calculus. To use integral calculus, like I want to I want to do some job, and then at the end I feel that I need to make I need to make a okay, I forgot the name of the branch in the blacksmithy. In that, I need to do something that will cast it. I mean, create a pattern or mold. Means I need to do recreation of item. Makes sense? Like I want to create brick. Now I did everything, then I felt that it's not possible. Means I took mud, the soil mud, and then I did so many things. Then at the end, I prepared the mud. Then at the end, I felt that I need a mold. Inside mold, if I fill the mud, and then I tilt it, then it becomes a brick. Then so at the end, we need it. Similarly, but when we need the mold, when we need the when we need to create like this, and then using the mold has some kind of its own terminology. If I want so many bricks, then soil should be completely crushed, and then water should be enough in that. Then only I can use or mold or pattern into which I can put the soil, and then I can lay it down like this. Or if I'm using metal, iron or nickel or lead or whatsoever, then it has a set of principle before I use the mold. Similarly, if I'm trying to solve a problem, I'll come to a stage where I think I need integral calculus. Integral calculus has some kind of rule and regulation. From this point to integral calculus rule and regulation, how I can jump in? That is the idea we are bringing in. How I can jump. What is the rule and regulation of integral calculus? Integral calculus means fx dx. That's it. What is fx dx? X dx means x-axis, and fx is a function over axis. That is the height, y-axis. Fx is a function over x-axis, and there is a continuous fx is flowing like this, continuous, no breakage, continuous fx. If I do fx dx, it will calculate the area underneath it. This is the area under fx and dx. From point A to point B, underneath it will give. From point A to point A, zero area, no area. Okay, means if I want repeated addition to convert to integral calculus fx dx, then fx is like this, and dfx ds will give the area. Now I have to think about so many area, non-overlapping, so many areas, continuous. If I am able to represent by calculation in this fashion, then that will become integral calculus, because addition of so many non-continuous, non-overlapping area in fx dx only. Okay, that way. So whatever we are seeing, repeated summation I have to bring in the form of repeated summation. Then I have to jump to integral calculus. Jumping to integral calculus means repeated area addition is required. Repeated summation will not work. Repeated area addition of area, sub area. If someone brings in that fashion, then addition of that repeated area, repeated area, addition of repeated area is integration. I have to bring to that level, then I can switch to integration. We talked about calculation of volume of a sphere in the last section. Calculation of volume of a sphere in the last section. Okay, can I calculate the volume of a sphere in Cartesian coordinate system? Okay, if I have a sphere, my sphere is very amazing. Okay, this is a sphere. Can I calculate the volume of a sphere through repeated addition? Now I cut this along z-axis, then cut it along x-axis, cut it along y-axis. Okay, if this is x-axis, this is y-axis, and this is z-axis, this is x-axis, this is y-axis, and this is z-axis. Now, I take a sphere, I cut along x-axis, I cut it along y-axis, I cut it along z-axis. N number of cut I am making from left to right, from behind to front, from bottom to top. So if I take one piece of volume that has a width of, if there is minus a to a is x, minus a to a is y, because it's a sphere, minus a to a is z, then each section has width as 2a by n, because I divided in chopped into n section. 2a by n, that is delta x. What is delta y? 2a by n again. And what is delta z? 2a by n. Means I have a small cube which has a width of 2a by n, length as 2a by n, and height as 2a by n. Okay, I believe it is all right. So now what is the volume of a sphere? Volume of a sphere is summation I equal to 1 to n, I equal to 1 to n delta xi, where delta xi is the section along x-axis cut. Okay, so I would repeat it. So what is the volume of a sphere? Summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Delta xi, delta yj, delta zk. Oh, was it that simple? Why we went with the sphere? Please watch our previous video. There we have talked about through repeated summation can we calculate the volume of a sphere. Here repeated summation we will calculate the volume of a sphere in Cartesian coordinate system. Okay, was it that simple? Okay, Now, summation of I equal to 1 to n, summation of j equal to 1 to n, summation of k equal to 1 to n, delta xi, delta yj, delta zk. Okay, now if we see this summation, then this summation is in form of a small volume. Okay, now but you said that now I want to convert it to integration because n tends to infinity. If n tends to 2 or 3, if n tends to 2, then we have I equal to 1 to 2, j equal to 1 to 2, k equal to 1 to 2, 2 to 2, 8 volumes are there. That I can add, no problem. If n equal to 10 also, then 1000. Full day I'll try. But if n tends to infinity, then not possible. How it's possible? Then we have to bring it to integral calculus. Integral calculus means integral calculus means x-axis and y-axis. X-axis, y-axis. Integral calculus means I have to bring it into form of fx dx. What is fx dx? If this is x-axis, this is origin and this is x-axis. On top of x-axis, okay, on top of x-axis, I have a continuous line. On top of x-axis, I have a continuous line. What is your continuous line? On top of this is x-axis. On top of x-axis, I have a continuous line like this. What is this continuous? This is x-axis. This is origin, and this is x-axis. On top of x-axis, I have a continuous line like this. If this equation of this line is fx, function over x, then fx dx is the area underneath it. So area underneath is like this. From where, hope it is area underneath it. From where to where? This is the question mark anyone would ask. Where to where? Area, area underneath it. Okay, from where to where? From this point, that is alpha, and this point is beta. This is alpha and beta. If I say this is function over x, this is y-axis. Vertical is y-axis and horizontal is x-axis. If I draw like this function over x, then from point alpha to point beta means this alpha is here, then it will go like this, and beta is here, it will go like this. Under this alpha to beta, whatever the underneath area is, that is fx dx. Fx means if I need to bring it, no, but I know many things. What you know? It can be fx into gx into 1 by hx into something like that. Then dx, dy, dz. That is also integration. I know. Fxy, function over xy dx. Fx, conditional, many things are there. How I can know that which integration I have to bring? How many integration you know? I know many integration. Fx dx, fxy dx dy, fxyz dx dy dz, fxy function over x and y, fxy dx. Okay, fxy dy. I know even fxy by d fxy by fy dx, fxy by fx dx dy. So many things I know. It will come to which integration? There is only one integration, and that is x-axis and function over x-axis. These are not available in any of the book. X-axis and function over x-axis. That is fx and x-axis. Fx dx. Fx dx will give the area underneath it. If I want to transform this summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n, delta xi, delta yj, delta zk into integral calculus, then I have to bring integral calculus, that is fx dx. What is fx dx? If this is x-axis, then this is alpha and this is beta. Then summation, integration sign, x equal to alpha to beta, fx dx will give the area underneath it. If I say that this area what I get from alpha to beta, if I chop it into n different parts and each section has separate area, if my repeated addition talks about addition of this section area, then if I add all, then I get the full area from alpha to beta. Then I can say x equal to alpha to beta fxd. Certain. This is what we are going to do. Whatever summation we have, if I transform that summation into summation of area strip, non-overlapping area strip, then from where to where it is going on x-axis, then I can bring it to integral calculus. Amazing, mind-blowing. Okay, let's try. Okay, now we have delta xi, delta yj, delta zk. This is the volume of the ith, jth and kth section, that we can call it dv, delta v. Altogether, I can say delta V. What are you meaning now? I am meaning it perfectly. It is now summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n, delta V. Delta V is the volume. Delta V belonging to I comma j comma k. I j kth section delta V is the net summation. Delta V, delta V, I can read delta V. Let it be delta V. Okay, now again I can rewrite this delta V. Delta V means the volume of one section. Volume of one section. Consider whatever volume is coming. Now there is a one axis called V. Can someone see this? What nonsense I am doing? Okay, now consider there is an axis called V. Make sense? There is an axis called V. V is an axis. And there is a function over V called FV. Function over V is FV. F bracket open, small v bracket close. Like fx. The way we write fx, I am writing FV. Okay. If I am writing FV like this, then can I rewrite now? Summation I equal to 1 to n. Summation j equal to 1 to n. Summation k equal to 1 to n. 1 1 into delta V and subscript delta V and bottom right, I can write as I, J and K. Delta V, I, J and K. Now what we have now? 1 into delta V, I, J and K. I, J, K section delta V. 1. 1 can I say it is function over V? Okay, now I have repeated summation now. Repeated summation 1 to n, I equal to 1 to n, repeated summation j equal to 1 to n, repeated summation k equal to 1 to n, and then function over v, fv, that is 1 constant, function over v into delta v I j k. Okay, function over v, someone can say that v belong to I, j and kth section, whatever it is. Now we have come to a stage where we have function over v into delta v. Means if I have a v axis, this is origin and this is v axis. This perpendicular, this perpendicular. If this is v axis, then this perpendicular is function over v. This is function over v and this is v axis. Okay, this is v axis and this is function over v axis. Now, if I am saying I have function over v delta v I j k. Now I j k, I j delta v I j k. Consider I call it alpha. Alpha, now I j and k means it will go n to the power 3 summation. Now altogether I write alpha equal to 1 to n to the power 3. Makes sense? Because it will go n to the power 3. Alpha equal to 1 n to the power 3. And then we have function over v, delta v alpha. Okay. Now more or less we have v section I have divided into n into 3 parts. N to the power 3 parts. V I have divided into n to the power 3 part, chopped it into n to the power 3 part. Each part area, each part area is function over V into delta V. If this is delta V, if this is delta V into function over V, that is the height, function over V, that is constant one. If I have height and if I have delta V, it talks about a subsectional area. Now, if I keep adding it, what you are adding now? I'm adding function over V when alpha equal to, for the section. There are many sections now that goes up to n to the power 3. First section, second section, third section, fourth section, ith section, like that. Now I can write function over V for v in ith section, delta v I 1 plus function over v in the second section, delta v 2. Like this, I can write like this. Now, everyone is sub. If I add all this subsectional area, it becomes a continuous area. If I add this area, this area, this area, the continuous area subsection, it will become a continuous area. Continuous area, if I talk, then function over the whatever the function we have into dv. Now I can rewrite now. Integration sign, function over v dv, where integration side will have limit of the volume from beginning to end. Make sense? Volume, what is beginning volume? Where when the sphere is zero, there is no sphere at all, centered at the zero. X equal to 0, y equal to 0, z equal to 0. That is the beginning sphere. And till the full sphere. So volume extend from v equal to 0 to full volume. And then function over v dv. That's where we make a cut, right? Okay. This is the how we turn the repeated summation into integral calculus. Thank you very much. Can you solve? Can you solve it? Okay, we will solve it. Function over v is constant 1. This is what we had taken. So 1. Take it out. dv. What is volume? Volume is dv can be written as dxy plane. This is the volume. Means delta x, delta y, delta z. That multiplication got transformed into delta v. Dx, actually it is delta dv. Volume is x into y into z. D of xyz means d of xyz cubical region. D of xyz, where xyz are orthogonal to each other. These are at 90 degree to each other. They are not collinear. 90 degree to each other, changing one will not change other. Now I can take it out as dx, dy, dz. Now I can write as dx, dy. Earlier dv, v become x into y into z. And since d of x, y, z cubical region, since x, y, z are orthogonal to each other, independent of each other, we can write as dx, dy, dz. Now we have integration of volume or integration of x into y into z from begin to x into y into z till end, dx, dy, dz. Okay, thank you very much. Can you now break the limit? Okay, we'll break the limit. We are not running away. Okay, so we are going to break the limit. Okay, so we will break the limit. Please break the limit. Okay, we'll break the limit. Now consider this is a sphere and it is centered at this is xy plane. If this is xy plane, the blue color here at the center is the origin. Now I place this inside this so that this sphere is centered at the origin. Half of the sphere is above the xy plane and half of the sphere is below the xy plane. If I think about this, then it will go inside. Now, if it goes inside, then on xy plane, it will form a circle. On xy plane, it will form a circle. The intersection of that sphere, consider there is a sphere, half of it is above xy plane and half of it is below xy plane. It will be a circle on the xy plane. If I just draw here, it will be a circle on xy plane where half of it is above, half of it is below. Now we have a limit where x into y into z from the begin and x into y into z till end. Now I want to break into x, y and z. Z will go from here to here. Okay, if this is x-axis, this is x-axis and this is y-axis, then y will go from here to here and x will go from here to here. Okay, now if I talk about z, then z is not constant. Z is not flat. Can someone see? If there is a sphere, then z is not constant. See, if this is x, consider this is xy plane. If I take different x comma y, the z, that is the height, everywhere height is different. Everywhere height is different. Z is not constant. Z vary with the x and y. Means z is a function of x and y. If I talk about the limit, how much it is function now? Z, x square plus y square plus z square equal to a square. A square is the radius of the sphere. Z equal to plus minus square root of a square minus x square minus y square. Means if I talk about the bottom and variation of z, then this is minus square root of a square minus x square minus y square. And this is the square root of a square minus x square minus y square. That is z. Okay, if I talk about now x and y relationship, then there is a circle on xy plane. Again, an x and y are related through a circle function. If I if I say if I say this is x-axis, if I say this is x-axis and this is y-axis, then at different x, y is not constant. Y should be a flat line. If this is x-axis, then y height should be flat line. But everywhere, if this is x-axis, then at this x, height is nothing, zero. But at the middle x, origin, height is maximum. Height is changing if I move along x-axis. Means x and y are related to each other if I take the limit. What is the equation of circle? X square plus y square equal to a square. Y equal to plus minus square root of a square minus x square. Means y will go minus square root of a square minus x square to plus square root of a square minus x square. X is independent now. X will go minus a to a. Now break it. Integration x minus a to a, y minus square root of a square minus x square to square root of a square minus x square. Z minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Dx, dy, dz. So we will take the z first. Dz integration is z from here to here. It will become 2 into square root of a square minus x square minus y square. 2 I can keep outside. Now it is square root of a square minus x square minus y square dy dx. It became complex now. How to solve square root of a square minus x square minus y square dy? Consider y equal to square root of a square minus x square cos theta. Okay, y equal to square root of a square minus x square cos theta. Dy equal to square root of a square minus x square. I am keeping this as constant. And cos theta will become minus sine theta d theta. I can keep it. Now, square root of a square minus x square minus y square will become again a square minus x square and then sine square theta. Okay, in this fashion, sorry, cos square theta, I can take out square root of a square minus x square will come out. Okay, why I had taken square root of a square minus x square cos theta. Square root of a square minus x square would come out. Square root of 1 minus cos square theta will be, that will become sine theta. Sine theta. And now instead of dy, I'll write it as square root of a square minus x square minus sine theta d theta. Whole it will become a square minus x square minus sine square theta d theta. Now outside I will outside 2 is waiting. 2 is waiting. So I can keep this outside. A square minus x square. Outside 2, a square minus x square will remain outside. And here minus 2 a square minus x square. And here it will be sine square theta. Integration of sine square theta is theta by 2 minus cos 2 theta by 4. Where theta is from here to here. Where is here to here? We have y equal to square root of a square minus x square cos theta. This proves that cos theta, theta equal to cos inverse y by square root of a square minus x square. Y is from minus square root of a square minus x square to square root of a square minus x square. If I keep it, it becomes cos inverse 1, that is 0. Cos inverse minus 1, that is pi. Okay, then it will become pi to 0. Will become pi minus minus will become pi, and it will plus will become 0. So it will become minus pi, it will become pi to 0. Theta by 2 minus sine to 2 theta by 4. If 0 means all 0, pi means minus, now minus theta by 2. Now lower limit I am taking. So it will become minus pi by 2. Sine theta will again go away. Minus, outside minus is there. Now it will become pi by 2. Outside 2 is there. 2 and 2 gone. Pi will remain. Pi I can keep it. Now we have a square minus x square dx. A square minus x square dx. Integration will be a square x minus x to the power 3 by 3 minus a to a, minus a to a. Okay, if I do minus a to a, now I'll take a first, then a to the power 3 by a to the power 3 by 3. That will become, a to the power 3 minus a to the power 3 minus a to the power 3 minus a to the power 3 by 3. 3, 3. That will become 2a to the power 3 by 3. If I take minus a, it will double it. 4a to the power 3 by 3. Outside pi is there. 4 pi a to the power 3 by 3 is the volume of a sphere. This we tried from the repeated summation. We will do this. This was, I don't think it was very deep. Integration was difficult, but bringing to integration was not that difficult. Oh, someone had to follow the procedure. We will do many things. We will do vector and vector calculus and other things. We will take other example also. In repeated summation brings the to integral. How we make jump, repeated addition, repeated summation to jump into integral calculus. That is the concept that we are pursuing. We will have not very easy time, very difficult time will also come. Anyway, please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.